Physiology Bio 201. Apologize for the sound quality of this one. I have a microphone on its way from Amazon, which should help, but this will give you an idea of what PowerPoints are going to look like in the, let's call it the aftermath of this extended break. So we start Chapter 5, the integumentary system, which you have already covered, but I just want to start again giving you a feel for what might look like. And I'll remind you the integumentary system is not just our skin. Skin is a big part of it, but also the things that are derived from skin, which include hair, our nails, toenails, and fingernails, sweat glands, even, and some sebaceous glands or oil glands. The skin is made up of two distinct regions, the epidermis and the dermis. The epidermis is that outermost region, the superficial region. It's epithelial tissue, it's avascular, there are no blood vessels in it. Below that is the dermis, which is mostly fibrous connective tissue. That does have a good blood supply, and the nutrients in that blood have to make their way to the lower regions of the epidermis to help the epidermis survive. Now, below the epidermis and the dermis, there's another structure called the hypodermis. It is also referred to as the superficial fascia. It's a subcutaneous layer underneath the skin. It is not part of the skin. We don't really have it as part of anything else either, so we do talk about it here. It is adipose tissue that absorbs shock, helps insulate our body, and it does very much anchor our skin to the underlying structures of the skin, and that would include mostly muscles. It is also the location that you are trying to get a hypodermic needle to give its dosage in. So here is the skin. Our epidermis is up here, the first brown layer here. Below that is the dermis, and below that, down here, they have the hypodermis. It's not really part of the skin, but we did the superficial fascia. This layer of epidermis is going to be divided into other layers. The dermis is divided into two layers as well, papillary layer and the reticular layer. So let's take a look at the epidermis first. Epidermis is keratinized stratified squamous epithelial cells. So they are cells that appear in layers, stratified, and those cells produce a lot of a protein called keratin, so they are called keratinized. And within the epidermis, there are four types of cells. They're not all keratinized epithelium. First are keratinocytes. They produce a fibrous protein, and that fibrous protein, keratin, gives skin most of its protective properties. They are the majority of the cells in the epidermis. They are held together with tight junctions called desmosomes. And on the top layers, we lose millions of them every day. There are also melanocytes, which have a more spider shape to them. They are deep in the epidermis. They produce the pigment melanin. That pigment melanin is packaged into melanosomes, and those melanosomes are then transferred to keratinocytes, and the keratinocytes use that pigment melanin to protect their nucleus from the damage that could be caused by ultraviolet radiation from the sun. In addition to keratinocytes and melanocytes, we have dendritic cells that were traditionally called Langerhans cells. They are macrophages that patrol deep within the epidermis, and they are very important for getting the immune system activated if that becomes necessary. There are also touch receptors in the epidermis. These are called tactile cells, and they used to be referred to as Merkel cells, and they sense touch. Epidermis is made up of either 4 or 5 distinct layers. Most of our skin has 4 layers. There are a few places where we have thick skin that have 5 layers. The thick skin has an extra layer, and it's found in places where there is a lot of abrasion, a lot of wear and tear. So on our hands, on the soles of our feet, thin skin lacks that layer, which is called the stratum lucidum. So in thick skin, we have stratum basale at the bottom, going outward, stratum spinosum, stratum granulosum, stratum lucidum, and stratum corneum. If most of our skin, however, only has 4 layers, most of our skin would start with stratum basale, go to stratum spinosum, stratum granulosum, skip the stratum lucidum, and go to stratum corneum. That stratum basale, the basal layer, is the deepest of the epidermal layers, the base layer, where the name comes from. It's firmly attached to the dermis. It has a single row of cells, and these are stem cells. Stem cells are able to actively divide using mitosis, and when they divide, they produce 2 daughter cells. One of those daughter cells will become usually a keratinocyte and make its way to the surface after 25 to 45 days. And as it's going up that path, we'll see it dies and becomes more or less a bag of keratin. The other daughter cell remains in the stratum basale and is a stem cell. So this layer is also called the stratum germinavedium because there is active mitosis, active germination going on within this layer. There are some 10 to 25% which are melanocytes found in the stratum basale. Above that is the stratum spinosum, which is the prickly layer, the spines, spinosum. It's several cell layers thick, and cells have a web-like system of intermediate prekeratin filaments attached to desmosomes. Those filaments allow them to resist tension and pulling. And the keratinocytes in this layer are spiky, so they are also called prickle cells, and scattered among the keratinocytes are melanosomes and dendritic cells. Stratum granulosum, or granular layer, it's above those. It's about 4 to 6 cells thick. Cells in this layer are flattened, however, and so the layer itself looks very thin. The cells are changing appearance. They become flattened, as I said. Their nuclei and organelles are disintegrating. Keratinization is beginning, and the cells are accumulating a protein called keratohyalin in the form of granules that will form the fibers that form in the upper layers. They also are accumulating lamellar granules, which are water-resistant glycolipids that help protect against water loss. This is the last layer that is close enough to the dermis to provide nutrients to these cells. So any cells above the stratum granulosum are dying. Stratum lucidum, only found in thick skin, so not most of our skin. Palms of our hands, soles of our feet. It has a thin, translucent band of 2 to 3 rows of clear, flat, dead keratinocytes just above the stratum granulosum. In most skin, we would go right to the stratum corneum from the granulosum. The stratum corneum is 20 to 30 rows of flat, no nucleus, anucleated, keratinized, and these are dead cells. This is 3/4 of the epidermis thickness. And even though these cells are dead, they have a vital function. They protect the deeper cells from the environment. They prevent water loss, making the skin waterproof, protect against abrasions and penetrations. And they serve as bacterial, chemical, and physical barriers to protect us. The changes that cells are going through in this process of moving from the bottom to the top is called apoptosis, which is a controlled or programmed, genetic program, cell death. Dead cells will slough off as dandruff and dander, and we shed about 50,000 cells